Hello friends, today we are going to learn the chapter number 2, mathematical methods. In previous chapter we had studied the units, the physical quantities, their units, their dimensions, etc. And we concluded that units are necessary to quantify the physical quantity. We also need to understand that all physical quantities may not be described by their magnitudes and units alone. There are some physical quantities which requires the position, which requires the direction, and to find out the position of the object or the physical body, you require the direction. So for example, if you are given the time for which a man has walked with a certain speed, you can find the distance traveled by the man, but you cannot find where exactly the man has reached unless you know the direction in which the man has walked. That means you require the direction for its exact location. So only magnitude or only the unit is not give is not given you the direction of the man, so that such physical quantities which need not the directions are called as scalar quantities. So scalars require only the only the magnitude. So here are some scalar quantities. See, in this picture we can see the car. Here the length of a car is 4.5 meter. That means the length is called as the here is length is the physical quantity and 4.5 meter is the magnitude. So length of the car or the mass of the gold bar is 1 kg. So 1 kg is the magnitude and mass is the physical quantity. But in both the cases, you need not require the direction so that you can visualize the object. You didn't require the direction of the object, only the mass, only the length is fulfilling your requirement, so that you can quantify the object. The time also here, the time is the one more physical quantity. So in the clock shows you some timing, that 12.76 second is the magnitude. The temperature, thermometer's temperature is the physical quantity, and magnitude is 36.8 degrees Celsius is the magnitude. So all this physical quantity didn't require the direction, only unit is required here, so that all those quantities are called as scalar quantity. So scalar doesn't require direction. only magnitude is required for scalar quantity. So here are some examples of the scalar quantity. Mass is the scalar, length is the scalar quantity, time is scalar, temperature, volume, density, etc. are the scalar quantities. So what do you mean by vector quantity? So vector is the another type of the object. Vector is the another type of the physical quantity. So vectors are such physical quantities which require the unit as well as direction. The unit as well as the direction. The physical quantities which need magnitude as well as direction for their complete description is called as a vectors. So here is a map on the board, and that map gives you the position of California from the North Carolina. Now the position is the physical quantity here. So they have given you the position of California from North Carolina is 3600 kilometer in west. So you require the dimension, the unit, magnitude as well as the direction. So if you will go to west, then you will reach, if you will go 3600 kilometer west of the North Carolina, you will reach to California. But if you will go to east of North Carolina, then you will reach in another country. So here the direction is very, very important. Okay. Now, so that we can define vector as the physical quantity that has both magnitude and direction. So here are some examples of the vector: position, displacement, velocity, acceleration, momentum, force, etc. All these require direction. All these require direction. Okay. Now, how one can represent the vector? So that diagram gives you the representation of the vector. A vector can be represented by a directed line segment or by an arrow. That means, first of all, go through this diagram. So if I there are 2 points which are very, very important for representation of the vector. The first dot and second dot. That the first dot of the arrow is called as tail of the vector, and the second dot on the arrow is called as the head of the vector. So if I will write here P and Q. So the first point of the vector is P and another second point is the Q. Then the initial point of the vector or the vector can be started from the point P or the tail point. So tail point is the initial point and Q is the head point. That head is the terminal point or the, so it's a, in general Q is called as the destination of the vector. So it can be written as, vector PQ, that that implies P is the tail of the vector and Q is the head of the vector. Okay. So this is the symbolic form of the vector. So if, see, here is vector AB. So this point A is called tail, B is called as head, and between A and B a line is there. That line is called as the magnitude. That line is called as a magnitude. And if it makes some angle with the horizontal, then that theta gives you the direction of the vector. Theta gives you the direction of the vector. So this is the symbolic representation of the vector. Now the next slide shows you the types of the vectors. How many types of vectors are there? First one, which is included in your syllabus also, zero vector, or it is called as the null vector. Null means no magnitude is zero. So the vector having zero magnitude with a particular direction, but it has some direction, then the vector is called as zero vector. So the velocity vector of the stationary object or the stationary particle is the null vector. So if, let us take the example of the velocity vector. The box of a mass m is placed on the table. At time t is equal to 0, the this is the position of the particle. Okay, and after time t is equal to 5 minutes or 5 seconds, the particle remains here as it is. Then that means it is at the rest. After 5 minutes it will be at the rest. That means the initial velocity of the particle is 0, so vector v1 is equal to 0 and vector v2 is equal to 0. Now the magnitude of the vector may be 0, but it had some specific direction. So this is, you can say that the vector, zero vector, has a zero magnitude but had some specific direction. Then the resultant vector. Resultant vector is the vector of two or more vectors. The resultant vector of two or more vectors, that is that of that single vector which produces the same effect of the effect produced by all other vectors. Let us take an example. Takes an example. See, here are some forces, say F1, force F2, forces F3, and one have to find out the resultant of these two vectors. Now that means you have to show the vector which has the component of F1, F2 and F3. That means it has to produce the same effect of all these three forces. And if it will be here, that means you can say that this is the vector R. This is called as the resultant of this force. So in other language, vector R will be equal to the vector sum of F1, F2 and F3. So it may give the same effect of the addition of these or all these three forces. So this is called as resultant vector. Unit vector means the vector having unit magnitude 1. Unit means 1. It has only, so one magnitude will be there. Then that vector is called as unit vector, and unit vector is denoted likewise that. So if you have a vector u, then its unit vector is shown like that. So it is that symbol is called as a cap. So u cap, if your vector will be u, then its unit vector will be u cap. So u cap means it has it has magnitude equal to 1. It has the magnitude equal to 1. And it can be, you can find out the vector, unit vector, by this formula. So it must be carefully noted that any two unit vectors must not be considered as equal, because they might have same magnitude but the direction may be opposite. If you have two unit vectors, now one possibility is there, u cap and minus u cap. Here both having this u cap and this is minus u cap. Here both having magnitude 1, but both are not equal. Why? Because the minus sign indicates that the minus u cap is opposite, it has opposite direction that of the vector u, that of the u cap. So though both vectors are unit, they are not equal. Then equal vectors are said to be, when two or more vectors are said to be equal, their magnitudes and direction both are same. So this word is necessary. The magnitude and direction are same. Then you can say that the vectors are equal. If you have the vectors, if you have vector p having magnitude 5, and if you have vector q having magnitude minus 5, see, the numerical value of the magnitude is same but direction is opposite, then you cannot say that the vector are equal. Okay, then the position vector gives you the position of the object. A vector which gives you the position of the particle at a point with respect to the origin of a chosen coordinate system is called as position vector of the particle. So if you have to find out the position of this particle, then you have to choose some system. So if I will use the Cartesian coordinate system, x and y coordinate, and then I can find out the direction, the position of the object from the origin, likewise that. So that vector is, if you call vector r. So that vector r is called, or O if the origin and P is the point, then vector OP is the position vector here. OP is the position vector.